Hi, quick video here on chapter 12.3, equations of lines dealing with vectors. All right, here we go. Example 1, we are given the vector, write the equation of the line containing the point A, which is a point 1, 3, 5, and vector U, 2i plus 3j minus k. All right, well, let's look really quick and see how do we construct the equation of a line in vector land. Well, r is our final position. Then we have r naught, which is our initial point, so where it starts. And then we have t, which is a scalar multiple, typically dealing with time. And then finally, u, which is the direction vector. Okay? So we need all these components, very similar to y equals mx plus b, in that you have an initial point, and then you have some type of scalar multiple, and then you will need a direction vector like a slope type of situation. All right, so let's go back to the problem and see how do we construct this. Well, in this case, our initial point was given as A, so we will list that as R equals 1, 3, and 5 plus a T value. And then here's our direction vector, the vector U, which was 2, 3, negative K, which transforms to negative 1. So here's our basic equation. That's our linear equation for this vector. Now, Part B says, find the position after 2 seconds. In a lot of these situations, you're going to have to find a position after so much time to see if two planes are colliding or what they're going to do. So in the basics, you have, if t is equal to 2, I take my r value of 135 plus, substitute 2 in for t, times the position, times the direction vector, and we get 135 plus, after I distribute this 2 across, we get 4, 6, and negative 2. And finally, I add those together, and we get our final position of 5, 9, 3. Now, I would encourage you, if you need to, graph this to see if it works out right. You can even change the values and get rid of the k value if you want, and see if you could come up with just the x and the y value if you wanted to do it on a normal Cartesian plane. All right, now we have another part to this question that they want to know. Write the parametric equations for the x, y, and z. So write the x, y, and z parametric equations for r that was listed before. And if we do that, we get x is equal to 1 plus 2t, and we took that directly from the x or the I category in the direction vector. The initial point, y was equal to 3 plus 3t. Again, 3 was in the initial point, 3 was in the direction vector, and then t, and z was equal to 5 minus t or minus 1t from the direction vector. All right, well, I hope that helps. Just a quick little tutorial on how to write a general equation of a line. Feel free to pause the video, rewind, go back, and look through it again. Hope you have a great day. The next video will have information on finding out if two lines could be skew or parallel, or maybe they intersect. Okay? So have a great day. Talk to you soon.